I would like to go over the combinatorial proof of Pascal's rule using the double counting or counting in two ways technique, which is essentially showing that two expressions are equal by demonstrating that they are two ways of counting the size of the same set, in this case, the set of combinations at hand. So Pascal's rule is going to be n choose k, and that is equal to n minus 1 choose k minus 1 plus n minus 1 choose k, where k being an integer from 1 to n minus 1 inclusive. Okay, and the reason why we have this restriction for k is so that the number of things you're choosing is less than the number of things you're choosing from. Okay, we don't want k to be n, right? Or else we have n minus 1 choosing n. That's not good. You could say by conventions equal to 0, but I'm trying to make it palpable over here, so that's why I have this. And likewise, I don't want k equal to 0 as well, even though it's possible right here. In order to break it down, I'll get negative 1, which is also not good. Okay, so I'll have this restriction over here for k. Now, of course, if you learned this in high school, you could certainly prove Pascal's rule by plugging and chugging it into the combinations formula right over here. But a combinatorial proof doesn't require us to use the formula per se. It uses sound reasoning instead. So I'll give a basic example for now. Here, I'll call this the symmetry of binomial coefficients. Okay? And we have that n choose k is equal to n choose n minus k. And here we can have k ranging from 0 to n inclusive. Okay, so how do we say that these two are equal to each other without plugging it into the combinations formula? Okay, so the double counting or counting in two ways technique goes like this. It's something like storytelling. So what I can do is that for the first one, I can say that choosing k shirts to pack up for vacation from n shirts that I have in the closet is going to be n choose k. Okay, and that is equivalent to choosing n minus k shirts to leave behind, which is n choose n minus k. Okay, because these two are going to imply each other. Okay, if you have n shirts in the closet, choosing n to pack up is equivalent to choosing n minus k to leave behind. So therefore, n choose k is equal to n choose n minus k, where k is between 0 and n inclusive. All right, so now let's get back to this Pascal's rule formula. So what can we do? What story can we say? Of course, there's a variety of different ways to do this, but I'm going to use the vacation and shirt from closet example again. So we're going to arbitrarily choose a shirt, I'll call it S, from n shirts in the closet, okay? Now, we want to choose k shirts to pack up for vacation, all right? So that's going to be n choose k. Now here's the thing. Every possible k-shirt combination must fall into exactly one of the two disjoint or mutually exclusive cases, meaning that there's no overlap between these two cases. You're either in one or the other, but not both. So case number one is this. So that shirt that you selected, okay, you pack it up. S is packed up, which implies that there are n minus 1 shirts remaining in the closet, and you still have to choose from it k minus 1 more shirts to pack up. Okay, if you want to choose k shirts to pack up, you packed one up already, which is S. The total amount is n minus 1, and then you still need to pack up k minus 1 more, which is this, n minus 1 choose k minus 1. Now the second case is that S is not packed up, which means that you keep S in the closet, so you disregard it, okay? Pretend it doesn't exist, which means that how many shirts can you choose from in total? N minus 1 shirts. There are n minus 1 shirts remaining in the closet, but you still have to choose from it k more shirts to pack up, because currently your suitcase is empty. So that is going to be n minus 1 choose k. So if we add up all the combinations from case 1 and case 2, that will give you every possible k-shirt combination. So therefore, n choose k is equal to n minus 1 choose k minus 1 plus n minus 1 choose k, where k is between 1 and n minus 1 inclusive.